Welcome to Podcast Learnin' Fun. Let's start tonight's journey of learning.
Mm.
Have you ever tried to really picture how two objects in space, like say a planet and a star,
Yeah,
actually move around each other? It's kind of mind-blowing, right?
it's pretty wild. Yeah.
Today, we're going to be looking at a concept
Okay.
that helps us kind of make sense of these complex interactions.
Sure.
It's called reduced mass.
Right. Reduced mass is it's like a brilliant tool
Yeah.
that physicists can use to simplify these really kind of intricate systems.
Yeah.
And instead of getting lost in like the individual movements of each object,
Right.
we can think about them as a single entity with like a new combined mass. And this reduced mass helps us focus on how the objects move relative to one another,
Mm.
like their dance steps, rather than their individual like footwork.
Ah.
You know what I mean?
So instead of two separate objects pulling and tugging on each other,
Yeah.
we can imagine one object with this special reduced mass
Mhm.
moving under the influence of their combined gravitational forces.
Yes,
That sounds incredibly helpful.
it is.
Yeah.
And the formula for calculating reduced mass is actually pretty straightforward.
Oh, good.
We just multiply the masses of the two objects together
Mm-hmm.
and then divide by their total mass.
Okay.
It's a simple equation.
So no magic wands involved.
No magic wand, just
That's
some clever math.
Clever math.
Right.
But what's really fascinating to me
Yeah.
is how this idea of reduced mass
Uh-huh.
impacts our understanding of the universe at vastly different scales.
Right. Does.
From planets orbiting stars
Yeah.
to atoms vibrating within a molecule.
Exactly.
Reduced mass plays a crucial role.
Yeah. It's like having the special lens
Okay,
that allows us to zoom in
Right.
and zoom out,
got it.
revealing these hidden patterns and connections.
Oh, cool.
For instance, in astronomy,
Okay.
reduced mass helps us analyze the motion of binary stars.
Oh, wow.
So that's two stars orbiting around their common center of mass.
Got it.
We can use reduced mass to accurately predict the orbital periods of these stars.
Okay.
Basically, how long it takes for them to complete one full dance around each other.
That's amazing.
Yeah.
It's like we're choreographing the movements of stars billions of miles away.
Exactly.
But what about on that much smaller scale?
Yeah.
Like
yeah.
the tiny atomic dances that you mentioned. How does reduced mass apply at that molecular level?
Okay, so think of two atoms that are bonded together in a molecule.
Uh-huh.
They're not static.
Yeah.
They're constantly vibrating back and forth,
Okay.
like tiny weights on a spring.
Huh.
And the frequency of these vibrations, it depends on the masses of the atoms and the strength of the bond between them.
Oh, okay.
Right.
So just like if you have a lighter weight on a spring,
Right,
it'll vibrate faster than a heavier one.
exactly.
So lighter atoms within a molecule
yeah.
will also vibrate at a higher frequency.
Right, exactly.
Okay, I get it.
And so this is where reduced mass becomes really important because it allows us to factor in the masses of both of those atoms
Mm-hmm.
and determine how quickly they'll jiggle around.
Right.
This information is really crucial for understanding how molecules interact with light.
Wait, so the way that a molecule vibrates, which is influenced by its reduced mass, determines how it absorbs and emits light.
Exactly. It's like each molecule
Oh,
has its own unique vibration signature.
Huh.
And this signature shows up in the way that it interacts with light.
Huh.
And this concept is actually fundamental to a technique called spectroscopy,
Okay.
which scientists use to identify different types of molecules based on their light fingerprints.
That's mind-blowing.
Yeah.
So it's like we can hear the music of molecules
Yeah,
by analyzing the light that they emit.
pretty much.
But can you give me like a specific example
Sure.
of how reduced mass helps us to understand a particular molecule?
Absolutely. Let's take the hydrogen molecule.
Okay.
It's the smallest and the most abundant molecule in the universe.
Okay.
It's composed of just two hydrogen atoms.
Right.
And because hydrogen atoms are so light,
Ah.
the reduced mass of a hydrogen molecule is exceptionally small.
Yeah.
And this leads to an incredibly high vibration frequency.
Oh, wow.
And this high frequency vibration, it has significant implications for the behavior and properties of hydrogen,
Really?
affecting everything from its role in star formation
Wow.
to its potential as a future energy source.
It's amazing how this concept of reduced mass can have such far-reaching implications. We've gone from the vastness of space
Right?
to the tiniest molecular dances,
Yeah.
all thanks to this idea of reduced mass.
Exactly. And what's even more fascinating is how it helps us to bridge the gap between those vastly different scales,
Right.
revealing the underlying unity and elegance of the physical laws that govern the universe.
It's a reminder that sometimes the most profound insights
Yeah.
come from simplifying these complex systems and finding those hidden connections that kind of tie everything together.
I agree. Yeah, it really highlights the power of these mathematical tools to not only describe the universe, but also reveal its hidden symmetries and patterns.
It does. But I'm kind of curious.
Mm.
We've been talking about how reduced mass simplifies things.
Hmm.
But are there situations where this simplification might break down or become less accurate?
That's a great question. You're right. Like any model or tool,
Yeah.
reduced mass does have its limitations.
Okay.
For example, when the masses of the two objects are very different, the concept of reduced mass might not be as useful.
Okay.
So think of like a tiny satellite
Right.
orbiting a massive planet.
Yeah.
The satellite's mass is so insignificant compared to the planet that
Right.
using reduced mass wouldn't really simplify those calculations all that much.
I see. So it's kind of all about choosing the right tool for the job.
Yeah.
But even in cases where the masses are quite different,
Mm.
reduced mass can still provide some valuable conceptual insights.
Oh, absolutely.
Right.
Yeah, it still helps us understand that the motion isn't just about like one object orbiting another.
Uh-huh.
Both objects are actually moving around their common center of mass.
Okay.
Even if that center of mass is super close to the center of the more massive object,
Right.
it still emphasizes the fact that both of those objects are participating in this like cosmic dance.
That makes a lot of sense. It's a nice reminder that even in seemingly simple systems,
Yeah.
there's always a deeper level of complexity waiting to be explored.
Right.
But let's shift gears a bit.
Okay.
We've been focusing a lot on gravity and orbital mechanics,
Uh-huh.
but I know that reduced mass also plays a really crucial role in the quantum world.
It does.
Can you tell me a bit more about how it affects things at that subatomic level?
Of course. In the quantum realm, things get a little more abstract and counterintuitive.
Yeah.
But even there, the concept of reduced mass is incredibly valuable. For example, when we talk about an electron orbiting an atom's nucleus, we can't really think of it as a tiny planet circling a star.
Right.
Quantum mechanics tells us that electrons behave more like waves.
Right.
Smeared out in space, they form these like probabilistic clouds around the nucleus.
I remember learning about those electron clouds back in chemistry class.
Yeah.
But I always struggled to visualize what they actually represent.
Yeah. It is kind of a challenging concept to grasp
Yeah.
because it really defies our everyday experience with the macroscopic world.
Right.
But here's where reduced mass comes in.
Okay.
Even though we can't pinpoint the electron's exact location or its trajectory,
Uh-huh.
we can still use reduced mass to simplify the equations that describe its behavior.
Okay.
It helps us to calculate the energy levels of the electron in the atom
Okay.
and also predict how it will interact with light and other particles.
So even though the electron's motion is all fuzzy and probabilistic, we can still use reduced mass to make sense of its energy and interactions.
Exactly. And what's remarkable is that these calculations, based on reduced mass,
Yeah.
match up perfectly with experimental observations.
Wow.
It's a testament to the power of this concept to bridge the gap between our theoretical models
Right.
and the actual behavior of matter at the subatomic level.
It's like we're using this mathematical lens to peer into the heart of atoms and decode the language of the quantum world.
Exactly.
But I'm wondering, you mentioned that reduced mass helps us calculate energy levels in atoms.
Uh-huh.
Could you kind of elaborate on what those energy levels are
Yeah.
and why they're so important?
Imagine an atom like a tiny staircase.
Okay.
Each step on the staircase represents a different energy level that an electron can occupy.
Okay.
Electrons can jump between those energy levels by absorbing or emitting photons of light.
Okay.
And the energy difference between those levels, which we can calculate using reduced mass,
Right.
determines the specific color or frequency of light that is emitted or absorbed.
So the color of light that we see is directly related to the energy jumps of electrons in atoms.
Yes.
And those jumps are influenced by reduced mass.
Exactly.
Wow.
And this connection is at the heart of spectroscopy,
Right.
which I mentioned earlier.
Yeah.
By analyzing the light emitted or absorbed by different substances, we can identify the elements and molecules that are present.
Wow.
We can determine their temperatures and even study distant stars and galaxies.
That's incredible. It's like we're deciphering the fingerprints of matter across the vast expanse of space.
Exactly. And reduced mass plays a really crucial role in this cosmic detective work,
Yeah.
allowing us to unravel the composition and behavior of matter from the tiniest atoms to the grandest celestial objects.
This has been like a really eye-opening exploration of how reduced mass connects seemingly disparate phenomena
It has.
from planetary orbits to atomic spectra.
Mm-hmm.
It really underscores the interconnectedness of the universe
Mm-hmm.
and the power of simple, elegant ideas to illuminate its mysteries.
Yeah, I couldn't agree more. It's a testament to the beauty and the power of physics to unveil that hidden order and the harmony that underpin the apparent complexity of the natural world.
It's amazing to think that this one concept, reduced mass, has taken us on this journey from the vastness of space to the intricate world of atoms and the quantum realm.
It really is a beautiful illustration of how, like, these seemingly disparate phenomena are often connected by these very elegant underlying principles.
You know, it makes me wonder what other secrets of the universe might be unlocked by applying this kind of like simplifying lens.
Yeah.
Are there any other areas of physics or chemistry where reduced mass is proving to be like a valuable tool?
Absolutely. One really exciting area is the study of ultra-cold atoms and molecules.
Okay.
So by cooling atoms down to extremely low temperatures, just a fraction of a degree above absolute zero, scientists can create these exotic states of matter where quantum effects become dominant.
I've heard about these ultra-cold atoms. It's like creating a mini quantum world in the lab, right?
Yeah. Exactly. And reduced mass plays a crucial role in understanding how these ultra-cold atoms interact and form molecules.
Okay.
Because their movements are so slow and their quantum properties are so pronounced,
Uh-huh.
we need to consider reduced mass to accurately model their behavior.
So even in this extreme realm of ultra-cold matter, reduced mass is still helping us navigate the quantum landscape.
Exactly. It's becoming increasingly important as researchers delve deeper into that quantum world,
Right.
exploring things like superfluidity and Bose-Einstein condensation, where atoms act collectively like a single wave.
It's fascinating to see how this concept that like originated in classical physics is now helping us to unlock the secrets of the quantum realm.
It really is a testament to the power of these fundamental ideas to transcend boundaries and connect different areas of science.
Yeah.
Reduced mass is a prime example of how a simple, elegant concept can have these really profound implications across a wide range of phenomena.
I have to say, I've gained a whole new appreciation for the beauty and interconnectedness of physics thanks to our exploration of reduced mass today.
That's great to hear.
It's a reminder that there's always more to discover,
Yes.
and that the pursuit of knowledge is a never-ending adventure.
Well said.
Well, I'm feeling incredibly inspired to continue exploring the wonders of the universe. Thank you for sharing your insights today and for guiding me on this incredible journey into the world of reduced mass.
My pleasure. And remember, the universe is full of wonders waiting to be uncovered.
Right.
And often the key to understanding them lies in finding those simple, elegant principles that connect seemingly disparate phenomena.
Thank you for listening to Podcast Learn and Fun. If you like our videos, please subscribe, click the like button, comment, and share. See you next time.